Hey kids, welcome everybody. Mark Miller here. Let's get some Code Rush music here going. Let's get down to the code here. I think I'm gonna need to get rid of that background. That's gonna be this button right here. There we go. All right, back in. We were having a problem where the fireball was flying up in the air and would kind of disappear. And I said I need to step away from the code. Well, I stepped away from the code, I don't know, what was it, 5 days ago? Now it's time to go back into that code, and I'm not sure, I got no, I have no insight since the last time I was here. So nothing, no dreams came to me, nothing with regards to fixing it. Let's duplicate the problem and see what that looks like. Here we go. Active. My fireball button's up. Fireball. Throw it. Okay, well. Hands down. All right, fine. It's still working. All right, let's see if we can get a catch. I feel like it needs to get a little closer to the hand, maybe. Where are you? There. Yeah, feels like it needs to get a little closer to the hand. There. All right. Well, not too bad. Where are we here? Oh, do I need to reactivate that window? Here we go. All right. Throw, catch. Throw, catch. Throw, catch. All right. A little bit of problem with regards to turning it around too, it seems like. I need to kind of come back in here, I think. Seems like if I'm going to turn around, doing it right over here is the best place to do it. Is there really a catch that occurs here? It's kind of like there's two throwing lefts there that are happening. Maybe not. I don't like how it kind of goes behind my head for a second here when I do the throw, because it's coming back. That's not too bad. Also, I don't like that, how it's not quite lined up with my hand over here. When I go back, we seem to lose it. Let's see if I move this a little bit. It seems a little bit more aligned, a little bit better. All right, let's try two hands. No. Why is that going away? All right, let's see if we figure out why that's going away. It's interesting. I can do a one-handed catch from one hand to another, or from one hand to itself, but not from one hand to another, it seems like. Looks like I got some snow falling here. Let's turn that off. All right. Switch in hands for a second. Is it? Yeah, it seems like throwing with one hand and catching with the other seems pretty hard to do. Where are we? Yep, that definitely is going away. There's something about one hand to second hand catch here that's not working out so well. Okay. Why do we get the remove? Check for catch. Okay, so we're removing it here. All right. So it makes sense that we're removing it, I think. Let's run it, because we've just caught it. Seems like there's something else we must be missing here. It's either something up here. Just caught is true. Switch over to TypeScript for a second. And following data tracks which hand we're in, and also has the tracking object index. And so if we have virtual objects, which one it was, what came out of it, I guess. We don't see caught down here, I think, when it's actually caught. In the other hand, I think, when it disappears. Are we at a breakpoint? We haven't started yet. This is weird. Oh, I've got the wrong thing started up here. Oops. That's not what I want. I don't think we're seeing caught. Let's see if we're still working. I think I have to lock the world instances here somewhere in this space. Like I'm good there. Not too early, Pudding. How you doing? We're going to change this. This guy Funks is with us. Hey, how you doing, this guy Funks? I was in a meeting. Sorry about that, guys. I was in a meeting for work a couple days ago, and CodeRush came up. Cool. Coding Gorilla Kids starts an hour earlier now that DST is over. Yep. Here, trying to figure out what I've got a throw and a catch with one hand, but a throw and a catch in the other hand is not working. And I don't know why yet. I'm just kind of cleaning up, changing some code around here, kind of slightly distracted by other errors that we're seeing where the collection's modified. It's often happening as I'm stepping through the code, so it's like, but you know, if I find the, you know, some kind of issue along these lines, I'm just going to add this code here to lock it. let's see, skeletal world, 2D instances. Yeah, so I lock before I serialize it, which I think is probably a really good idea. And I think that's it now. I want to do this actually. Doing all of these, kind of moving these in here. Okay, and I think that's a full loop all the way around. Let's try this now. Trying to get a catch from one hand to another. There's something different or weird about it. I can throw from one hand and catch in the same hand, but when I throw and catch in the other hand, the fireball just disappears. And I feel like it's one line of code. I got to find and I got to figure out where that line of code is. Let's also check. It just occurred to me I should look at source tree here. Looks like these are all my changes from last time here. Let's go check that code in. I worked on a weather system over the weekend for the D&D piece, which is actually pretty cool. And I'm going to actually tie it into the Code Rush show because I think it's so cool. And I'll do it this week. I'm going to make it so that you'll type a command in the chat room followed by a city name, and then we'll check the weather in that city, and based on the weather, we will simulate it here on the show. So ideally, it'll be fun weather like snow or thunderstorms and rain or fog, things like that. If it's just sunny, then there's not really, I don't have a sun shining up at the top. I suppose I could add that. Really staticky. Oh, thanks for that, Coding Gorilla. I was worried about that. I think I've got a problem. I think I got a problem with the mic. And I notice it's happening maybe when I move. So I've just adjusted a little bit. Is that any better at all, Coding Gorilla? Let me know if that sound is any better. And I should be able to listen to this as well. If this is really, really bad, I'm going to have to switch mics. I'm really bummed because this is a great microphone, but it does not last long. See if I can hear it here. Better? See if I can hear it here. Okay. Let me know if we hear if we have a problem again with that, Coding Gorilla. I appreciate that. Definitely want to strive for some high quality here. Let's see, what else do we work on here? All right. I modified these a little bit. I don't want to check these in yet. So leap calibrate, I'm not going to check in just yet. These numbers, I'm not convinced these are the best numbers yet to use. I kind of played with them a bit. Skeletal data, yeah, there's the locking code we added. Well, this is just all these changes this morning, it looks like, isn't it? Yeah, minor change there. So just like basically adding locks to it. Add a weather system, and yeah, that's it. All right, so let's stage all that with the exception of leap calibrator. Stage selected. Commit. All right. So Speaking of weather system, here, I'll demonstrate a little bit of it here. So let's create some light snow here. And that's kind of what it looks like. It's kind of like maybe heavier snow than I want light snow to actually look like. I think I want it to make it even less than that. But we'll try this for a while. If you don't like it or it gets distracting, let me know. You can also go with like drizzle. See how that feels, writing code in the rain. All right, so we've got the remove. The remove is actually correct. It's happening at the correct time. Call to remove instance is happening when we caught it. Check for catch is happening here. Check for catch. Remove out-of-bound instances set from frame. Wait, it's also got to be coming from... Yeah, we can only catch if a hand's in frame, so that makes sense. And we need to remove the instance after checking for the catch, so the next time in, when we come in with the other hand, we don't say we're going to catch that too. So that feels good to me. Here's where we send that data out. Yeah, it feels like the data, this is good up here. I feel like the problem is down below, is what I'm thinking. Oh. I think the problem is maybe here. Yeah. Here's the problem. The sprite has this hand following data associated with it. So when we throw the fireball up, in that first sprite, you know, we add a sprite proxy there, and we get its hand following data. Then we get its hand, is what we do. And then we check to see if the hand is just caught. The problem is the hand the fireball was thrown from is only going to be checked to see if it's caught. We need the other hand, is what we need. So what we really need is something, I think the code needs to look like this. If hand, then if hand.throwing. This dot check caught, check for catch. We need to pass in the hand and the hand following data. Just get my wrist straps on here. Okay, we need to do those two. And then I think I want this to return a Boolean if this dot just caught and return. No, I like it better before. Check for catch. And then what I want to do is down here is I want to say, I want to do a check for catch again, but I want to do it with the other hand. Check for catch is going to look like it's going to have this as the body. Good. Okay, that's better. What's my problem here? Oh. Maybe better to do this. Let's go back to void. So now what I want is something that's like get other hand. Probably easier to do an if statement here. Okay. That's a shot. That's got a shot at working right there, I think. So let's refresh. All right. Let's do this. It shows caught. Something is different about it. I'm not sure what that was. Too far away. Ah, what's happening? Hey, Retro Turkey. Ah, that's not bad. It's not bad. It looks like I am catching now. Cool. Yeah, it's going way far back. Whoa, whoa. That was crazy. I just bumped it. I like hit it. Boom. I didn't know I could bounce them off my hand. Come on. Here we go. It's a little bit of a mess. All right. All right, it's crude. It's crude. The whole Z-axis flattening thing looks really freaky. I'm not exactly sure what you mean by that, Coding Gorilla. I feel like the catching is a little bit... Oh, I think I know what you mean. I think you mean when it's way behind. Yeah. And you catch it in suddenly 100 pixels. Yes. I'm with you. The Z-axis flattening. I'm 100% with you. Let's see where that code is. Well, I can do something else in here too. Let's kind of set a breakpoint here, maybe. Let's see if we can. I think I'm going to need to get a fireball back here to get the breakpoint. Oh no, I don't. Okay, cool. How? Check for cache. I almost feel like I need this right up at the front. Like that. So I've got my exit fast out of there. This is like my more interesting breakpoint down here. All right. All right, there we go. Apologies for the distraction back here. I think I want to drop this down. I want to get this closer. I want to kind of make this require a greater degree of precision. And then I think I also want, let's rename this to min XY distance for catch. Not sure what happened here. I just suddenly jumped away from the line of code and reached another breakpoint. That was really, really weird. Okay. And then I want to create like a min Z distance for catch. And I don't know, we'll start it at this 200 for now. And then now what we can do is we can say, and virtual 3D object.z, right? Dot current position dot z minus do I have a palm position, oh, hand dot palm position 3D dot z, and I need a math absolute on that. Let's just do this. We call that delta z. Okay. And I want to say, and delta z is less than min z distance for catch. Let's try that. See how good or bad that looks or becomes. So right now the z distance for catch is about 200, which I think, if I'm recalling, we've got a distance about 400 between these. Between the farthest back my hand can go in this. So it's got to be kind of within this range, I think. We might want to actually increase that. All right, let's try it. So throw it back. And we totally missed. What was interesting also about that throwing it back is it got bigger, but it was the scale went negative, I think. And so we need to take a look at that. Oh, where's that? Why are you over there? It's because the other hand? I don't even know what's happening now. Let's try again. All right. Let's throw it up. Okay, that was weird. Let's throw it up. That's a catch. That's a catch. And that's a miss. So it looks a little less freaky, I think. Never mind. Oh, yeah, too far away. Definitely too far away. Be kind of careful with the way I throw it. Come on. What's happening back there? Oh! So that makes me want to increase the Z distance for the catch. Set a breakpoint there. Let's make it 300, actually. We'll try with 300. Definitely nothing there that I should catch. Didn't catch that one. Hey Nick, thanks for the subscription. Yeah, that was way too far back. Let's see if I can get this straight up. I'm not sure what happened there. That was weird. It just went off screen. I think the other thing, here's another thing that kind of bugs me. When we get about right here, it should just go to the front plane, even if my hand is backwards like this. It should kind of jump in front of my face when I move it across. That's what I think. I can kind of do this too a little bit, like that. That looks relatively realistic. But it's on the back plane because my hand is angled kind of back. Also, I think this distance is too great right here. I think it needs to be closer down to my palm. So let's work on that. This is crazy. It's a little crazy. Yeah, we might tweak this a little bit as we see yes or no with regards to catching. The distance, let's go look at that distance. Where are we calculating that? Is it just palm position? What's the position of the palm? There's an attach point I thought I had inside of the hand. Palm attach point, get attach point. Here we go. So this is the palm normal times the palm width. So what I want to do is let's cut this in half. So I'm going to take the width of the palm. Yeah, let's do that. All right, so here we go. Let's see if that looks any better. I don't know, it's kind of okay. I found that this is like the best kind of one a little bit. Well, I thought it was the case. Yeah, it's way better here on the back for it to be lower like that. What happened here on the front? It's like the front plane isn't drawing anymore. Why are we drawing? The front plane is locked. And I've seen this happen before when we've been testing the fireball. It's like the front plane is totally locked. Why would that be locked? I'm going to bring this up and initialize it as well because I want to see if there are any issues coming out over here with regards to the code that we have. So here's the front plane. When I turn my hand, it goes off of that. We saw it lock up net before. It's not locked now though, which is kind of interesting. What do I got over here? I got some errors. Okay. 1197, let's fix that. That's not my problem, but why did we lose it? Oh, is it because my hand closed maybe? I think it's detecting a hand close. That's why it's dying. Yeah, I can only do a closed hand if I'm holding it. That only makes sense. Closed. I think this may actually be down here. Is fist. Destroy all fireballs. We need to actually be holding it. If it's thrown, otherwise it's not. So here, whoops. I think we want the code here. So we're only, let's see, if position is equal to out is found, well, there's kind of two pieces to it. Here, if hand and the hand is a fist, then we're going to destroy all fireballs. That only happens there. Here, we're only going to destroy them if they're out of bounds. Okay, let's see if that is any better. Let's do a refresh here. Refresh there. Throw it, throw it, fist, good. It continues to go. That's great news. Okay. Come on. It's like there's times where the data coming in from the lead motion. Yeah, I don't like that. See my thumb right there? I'm really trying to get the turnaround to work. I almost think, yeah, this is like visually problematic. Right kind of here. I think what I want to do is if the hand is sideways, I think I want to come up with some special cases where if the hand is sideways and it's touching anywhere around where my head would be, right, that it switches to the front plane. So it stays on the front plane until we get out of the way. Rory says he might be just a few minutes late. What are you doing over there? All right, come back here. All right, let's see if we can get a hand throw and a catch. Too far back. Throw. 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 Catch. Throw. And too far. Okay. Where are you? It's interesting, it takes that as a throw. That's what I'm looking for right there. Yeah, it might be a little too sensitive on the throw. Let's go take a look at that code. I feel like I want to take this and put it much closer to the where we're checking to see that method. I think what I want to do is check to see if this change is happening far enough in time away from the fastest speed we achieved. Because what I think is happening, there's just a real quick burst and deceleration. And it's saying, well, those are right next to each other, 160th a second apart. But I want there to be more time between those two. That's what I want to do. So I want to set a breakpoint here. And okay. So going through, is this greater than min velocity for throw and a valid throwing direction? If so, then I want to say, okay. Escape velocity reach time is equal to checkpoint.time. Whoops. Clear local. I want to throw this up here. And I want to say, hey, if it's a min value, then I'm going to set it. Okay, so the first time we get to that velocity, so if we've got a long throw and we're reaching it, right, we're going to say, okay, we've reached it. Then I want to decide what's the minimum time before I can release, so that a quick move like that won't throw it, but a concerted effort. So it feels like it's about 1/10 of a second, maybe about 1/20th of a second. Hey,
Hello.
Ryan. How you doing?
I'm doing pretty good, my friend. How are you?
I'm doing pretty well.
It's raining.
I know, yeah, it's raining a little bit. I just got a text from my wife. I want to check it out here. What is going on here? That's really funny. So they made it. I don't know if we can see this or not, but let's see if we can see this. You kind of maybe see it. Whoops. Hold on. Let's try one more time. Bring that up. I'm going to try to get it right in the camera there so you can see it.
Oh, it's a hand? Is that a...
Yeah, you know what, you can't see.
Is that like an impression done on like plaster of Paris or something?
Yeah, no, it's not. Let me get you to another view of it. Hold on here. There we go. So this is a sign, and it's a sign on a seat. The seat had no problems at all. Let me see if I can get this thing in focus. I'm sorry, the seat sign was failing. It was basically saying, don't sit here. So somebody created a new sign with a hand, and the hand worked. People didn't want to sit on the hand, but they were fine sitting on the other sign. That was Karen. How are you doing, Roy?
I'm doing good. I am. I just had a ridiculous piece of inventiveness last half hour. I'm trying to work from home, as many people around the world are. We've recently gone back into lockdown, and my desk is too cluttered.
Uh-oh. Not on this show! You can't do this one! All right, sorry about that.
That's funny. Yeah. There are no words.
Sorry, Roy. You're saying what were you saying? I completely forgot.
I'm trying to work from home, as many people, and I'm trying to clear my desk, have less things on it. And I've got like a standard PC keyboard on my desk, as you might have on pretty much any computer person's desk. But I've also got a MIDI keyboard, like a piano style.
Oh, neat!
One.
I love it.
And the trouble is, I've got a shelf that the monitor stands on, a very short one, and I tuck the MIDI keyboard underneath, and it's almost completely inaccessible. And it's difficult to pull it out. So I was on Facebook and I was saying to people, does anybody know of a product I could use to sort of put that keyboard on casters and pull it out?
Oh,
sort of on a sliding mechanism. And one of my good friends, Amy Kimber, she suggested prototyping it in Lego. And so for the last half hour, I've had my kids out building wheeled rail devices.
That's not bad.
And it works perfectly.
That's awesome.
Brilliant.
I love it.
Now I can push my PC keyboard back under the shelf and under the MIDI keyboard, and then I can pull the MIDI keyboard out on its sort of coasters, and I have full accessibility to everything, whichever one I want to use.
Send us a picture. You don't have to do it now, but
Sure.
send us a picture. I'll show it on the show tomorrow if you want.
Cool.
All right, so I'm like, you joined us just in the middle of us. I'm trying to tweak this throwing. I noticed I would just like turn my hand and it would be like I'm throwing.
Okay.
And I wanted to not do it like that. And so I decided I'm going to create a minimum amount of time from the time escape velocity is reached to the time we detect a dramatic slowdown or a reversal of direction. So we need to have a minimum amount of time. And so I've stored the escape velocity reach time. That's the time we first reach it, only once, right? So we're going through all of the history. I'm going to store that once. Then in here, we're going to make a decision right here based on that. In fact, I think it's time to do that about right now, to write that code. If checkpoint dot time minus escape velocity reach time is less than, and I think it's going to be about, I think it might be about, or it's got to be greater than, sorry. It's got to be greater than, I'm going to make it 150 milliseconds. Maybe 180. I'm going to make it 180 milliseconds. Then we're throwing, is what I'm going to do. I'll change the breakpoint to there. All right, let's see what we can do. I may have totally killed signal R. I don't know. My theory is that being in a breakpoint for too long kills it, but I've also seen it just stay. No, it looks dead. Feels super dead. Oh, wait, that's working. Hold on, let's try again. Fireball buttons are not working now. Why would the main window works, but it's my connection to Twitch that seems to not be working? I think that's what it is.
I've just succeeded with a test wave from the chat room. And that's Twitch, right?
Yeah, that is Twitch. What the heck is going on? I don't know.
Is this one of those focus things? You have to have the focus of the
window
or one of the tick boxes.
I just got a breakpoint. Hold on, let's clear that breakpoint. We've got the new one where we're actually throwing. Okay, so there we got a throw. Let's run it again. Another throw, really? This is just so I'm turning quickly.
You shouldn't be able to have throw logic unless you've actually got the fireball.
Well, I think I'm doing a check for it right there. Now I'm not getting any throw. That should totally be a throw. What's happening, my friend?
It's not detecting anything, is it?
Is it? I don't know why. Let's see what I got. Fireball. Okay, there we got a throw. Let's try again. Quick turn. I'm looking for quick turns. That feels like better. That was a throw. What is this expression right here? What's my
184.
184. Okay. I want to crank it up then. Let's make it 240. All right, let's try again. That's good. That's good. There's a throw right there for real. Real throw. There's another real throw. That thing I think is the next bug I'm going to fix. It's it's passing the z-axis plane, I think, and what's happening is the calculated scale is going from positive to a negative, so it's just flipping it around. Does that make sense? What I'm saying? That's what I think is happening. All right, so let me do this. Let me demonstrate that bug. We'll go try and find that bug next. Okay. So here, if I throw it behind me, there, see it? In fact, you can even, it's actually, it's not the, it's the vertical scale, I'm not sure about the left-right scale, but the vertical one is definitely, see what happens? It's kind of getting further away, but it's flipping. I suspect that code is down in TypeScript. I thought I had code in here to check to see that if the scale was negative or not, and to solve that. That could be happening up here too, as well. Let's go find... I think it's scale point. To scale point. That's what we called that. To scaled point. There we go. Well, there's no protection here against scale right here. Delta scale is going to be front scale minus back scale. Those are constants though, right? Or no? Yeah, front scale minus back scale. Those are constants. That's what I want. Okay. So percentage Z is what must be negative. I think what I want to do is have a min scale. That's what I think I want to do. I'm going to close down the app and restart it here. We'll declare a new constant here.
So no matter how far backwards you throw something, it will only get yay small.
Right.
We've got to remind ourselves that your back plane is a predetermined point that was one particular set of calibration that you did at one point.
Yes, that's right.
Yeah.
So I'm gonna make the min scale 0.2. How's the weather over there, Rory, by the way?
Dark.
Dark.
Closing in on winter in this part of the world is, yeah, I think the light sort of leaves me about an hour ago.
I'm adding new weather effects for the show. I don't know, does this at all look like what it looks like over there? Is that a good effect for the show?
Oh dear. It's not quite that bad.
We can only work on code in the very middle of the screen, right in here. Just keep your eyes there.
It's all about the focus. That's
Everything
what it is.
will be fine. Yeah, so
no vision on the right place.
So I have visual effects that I added for the different weather conditions. This is for the Dragon Humper show. Which, by the way, kids, if you're not out there following it and you like Dungeons and Dragons, go out there and follow it. I just put the link in the chat room over there. But I added these...
Once again, we say kids, but kids really possibly should not watch this show.
All right, fine. Fine, Mom.
Possibly.
But I've got...
Viewer discretion is advised.
I also have... I also added... Oh, this isn't working. Oh, because nothing's running. My buttons aren't working because nothing's running. We have to run it first. But I have essentially different scene changes, and I figured out how to do this really in a cool way that allows me to kind of independently control layers that are being shown in OBS more than what I used to do. Because before, what would happen is, for example, if you cast a spell, like for example, Ice Knife, it would play this, but it would have the background be a steady background. There we go. Let's get out of that. It's pretty obnoxious. Anyway, here, let's go fix our scale problem here a second. So what I'm going to do is I'm going to say, I want to say math.max, whatever the highest value is, either my minimum scale or this. So I'm going to just do that. Yeah, I was going to comment on how unintuitive I find this max one, because I'm always thinking, well, here's my minimum value of the two. It's like I feel like I want to replace math.max and math.min, but I haven't really thought about it beyond just, oh man, I'm not liking it. It's a little bit, I always flip in my head. It's like I'm dyslexic for these method calls.
So quite frequently what I like to do is to effectively do, I guess you call it API by example, so you completely ignore what you've got and you just write out the call the way you'd like it to be.
Yeah.
And you get an instinctive idea, and then that's where Code Rush's declare from example
Yeah.
works so well.
Yeah, I think I would do something like math dot no less than, something like that. I know it's more wordier, you know, or at least, at most. That's what I would use. At least and at most.
That works.
I like that way better. At least, and then I put in my min scale, you know, and then the value I want to compare it with. Yeah, I like at least better than at most. Anyway, that's me. All right, we're up and running. Let's go start the leap. Make it active. Get my buttons up. Bring up Fireball. Give me a Fireball. There we go. Let's try the throw backwards. There we go. All right, so that looks like
pretty good.
That looked like that fixed it. All right, good. That's excellent. So forward, backwards is no problem. I also think forwards is no problem, but maybe I'm wrong on that. Come on, where are you? Give it to me. Where are you, Fireball? There you are. Forwards. Yeah, it kind of doesn't quite go. I gotta give it a kind of a little toss, I think, there. That one is a weird problem.
Yeah.
What is happening there?
That was okay.
Oh, yeah, also okay. Wow. Okay.
Okay, that was weird. That very weird. There's a whole bunch of false sort of catching.
Yeah, went off to the right and then
it appeared almost central.
Came back over on the left. I'm trying to figure that one out. What is happening there? So I don't think the problem is in the code we're looking at here. Yeah, let's go switch over down in this space. What method are we in? Update tracking effects. So we're getting the thrown object's position. Take that X position, subtract something. Yeah, I think the position, because all we're doing here is just setting the X position equal to that minus its origin.
Mm-hmm.
It's the thrown object's position is likely what's happening. It's not the hand position because it's a thrown object, which means our thrown object position scaled point is wrong. That means that's what we're passing down here. So let's go find our thrown object. Get thrown object from index. These are the thrown objects. Here's they are right here. Wait, this is in, yeah, skeletal data 3D. Okay, so here's what we've got. update. So get current position, and then current position to scaled point. Yeah, and then we're back in here again. Oh, here it is. I think this is here. This is my problem.
Okay.
I think the problem is that percentage Z gets negative. That's what I think is happening. Vector Z, yeah, vector Z gets negative as it goes forward. Gets smaller as it goes towards me, I mean.
Mm-hmm.
Wait, is that right? Throwing this way. Oh, I'm totally forgetting which way it is again. No, it gets bigger as it's going this way. So vector Z is getting bigger. So this number is not going to be negative here. It should not be negative. It should just get bigger and bigger as it goes towards the camera, which towards you is going to be flipped around the other way. But it does feel like a switch in the sign for this could explain.
So what if we were to stick some assertions in here? So effectively console write line kind of stuff that only pops up if our assumptions are broken. And then we could simulate this in the browser a couple times.
That's a good idea.
And see which ones were bad. So you can say percentage Z should never be outside of these bounds, or backplane should never be outside of these bounds.
Yeah, I think that what's interesting is when it does get what I believe is negative, when I throw behind, it still looks okay. You know, it is.
Yeah.
It's.
Any chance we're exceeding some value and wrapping round?
I think
max value.
You know what I think we should do, Rory? I think we should, instead of doing this, we should calculate what percentage Z needs to be equal so that our final scale result is that min scale value. So we change our percentage Z is what I think we do. And that could maybe fix this other problem as well. Let's see if I can get a breakpoint in here. I think I need to give that focus. There we go. Okay, so this idea is that I think it's going to go like this. I think it's going to say like, well, at least I'll start with this. If that is greater than my min scale, then I'm going to say percentage Z is equal to min scale minus back scale divided by delta scale. Why am I not seeing delta scale in here? Something's wrong with delta scale. Oh, delta scale is right there. I just need it up higher. Okay. Check my math, see if that looks right to you there. Subtract min scale from both sides. Oops, it doesn't look right. Wait. Subtract back scale from both sides. Okay, now this looks right. Divide both sides by delta scale, and I've got percentage Z. Okay, so that's what that code is going to do there. And then my scale. So I think this was the code I had right here. We don't need the min-max anymore. Is that, I think. I think that's the code. Any comments on that, Rory?
I have no reason to think you're wrong. Which is another way of saying I'm not entirely sure I followed it the whole way through, but...
All right, let's see if it works.
Seemed reasonable.
Let's just see what happens. I'll take it. If it fixes it, I'll take that as success.
All the kudos to yourself, obviously, in this case. Yeah. Lives or dies based on your code.
Where are you? Where's my fireball? Hi, Code Rush and chat. Yasmin and Dusa, welcome.
Welcome, Yasmin.
I had the wrong... What?
It's a very small fireball.
Okay, I think I've just got a sign wrong. Yeah, it's my fault. This should go this way. When I said sign wrong, I mean operator wrong, pointing the wrong direction. If it's less than min scale, we're going to do something about it. Wow! You really don't like it.
That's kind of harsh.
Got me here the last time, too. At this breakpoint. It's not the size of your fireballs that matters. Well, it does matter. We need them big. All right. Watch it, kids.
Near that.
Yeah, we can't get near any of that. All right, so let's see. Are we coming up? Where are we? Where are you, app? Where are you, Mr. Application? All right, there we go. Let's go turn on leap. Okay. Let's move this off screen so we got a nice dark background. And here we go. Okay, so now we got the bigger one. And I want to throw it forwards, actually. That was a mess. Try again. Where are you, Fireball? Okay, there's one that went. Nope. It's like it gets off screen and it kind of almost wraps around. Is what it feels like is happening.
Is it accelerating to the point where it's so far past? I don't know. It would still need to do something weird with the X, wouldn't it?
Yeah.
Well, is it going off to our right as far as the X is concerned? So it's not that you're throwing it forwards, you're throwing it forwards and slightly at an angle such that it's actually going sideways as well, and it goes off a different set of bounds.
Let's try it. So I just throw it far to the right, no big deal. And I think I've seen it go far to the left as well. No big deal.
So left is pretty good, yeah.
It's forward. Okay, my catch forward is ridiculous.
Yeah.
Let's go jump over to that. Caught.
I thought we had some kind of a minimum time for catch more than it was distance.
We don't. But that's a really good idea, though. And also, hi, Fred. Fred says hi back. Okay, so do I have the time this thing was thrown? I have its creation time.
Creation time of the thrown object, yeah.
So I think what I'm going to do... Oh, wait, maybe you're right. Look at this line of code. If now minus the creation time is less than a quarter second, I could increase it. So you're right, we did have that, Rory. I did not remember that. So let's go.
So if you're catching, if you're throwing, it's typically sort of up in the air and then back down. So you can have a fairly lengthy minimum time there.
I'll double it. Let's see what happens here now. That was better.
That was the one.
Yeah. It's kind of like it comes right off to the right here, and it's got to go forward. Yeah, the problem is I can't imagine where the code is, where that code is executing. I feel like I just throw it in the same place, and it didn't do it this time.
Yeah, I mean, that went right, but it didn't reappear.
That one did.
That did. So you need to do like 5, 6, 7 of these in a row and just get a feel for the exact, I don't know, physical movement that is causing it. Although that's going to be a tricky thing to do.
Yeah, I'm not sure that's... I kind of feel
It's
like
hard to unit test a hand.
I feel like your other suggestion was maybe a better one, which is put some assertions inside of the code. Two-scaled point. And I'm wondering if we've only got one object. We're calling two-scaled point. We're probably calling two-scaled point from a lot of places, though.
It feels like to scale point really can't be all that flawed given the number of places we're using it. And it's a fairly simplistic exercise, right?
Yeah, okay. So your hunch is down in this space here, but I think we just reviewed this, as I recall. Wait, not here. Was it here? Oh, yeah, maybe it was here. Yeah, I feel like we're getting close to it. Yeah. So if it's a thrown object, we're getting its position here. Here's what we could do. Well, yeah, I think I'm still feeling it back up in this space, up in the C# app. I think what we could do is we could set a breakpoint when the position switches from, you know, one side of the screen to the other. That's what we could do.
Mm-hmm.
So let's go find two-scaled point again. Let's go find this here. Current position 2D. Wait, what is this? This is in check for catch. Current position. Where's our skeletal data? What are we sending down? We're sending down thrown objects. Clear. Update virtual objects. We get the thrown object. Whenever we call update, we update its position. Here is its position. So I think what I need, can I get a breakpoint here so I can make some changes to the code? Do I need to fire up an object? There we go. Okay. New position like that, and then I want to say, hey, if new position dot x minus thrown object dot position dot x is greater than, I don't know, let's say like 500, then let's break like that. Okay. 1481 to 0. Let's just keep running because a lot of time may have passed in that. Let's try and get another one. That's what I want to do. So new, whoa, thrown object position is 0. Is that because it's the very first one?
Maybe.
And I'm going to say and thrown on position is not equal to 0. Let's try again. What do we got now? X was 3979. 31. Yeah, that's not a big deal. Change it to like 800. Keep running it. I'm looking for a big change the other way. If they're it's greater than and this one is less than, like, say 2000, or new position dot x is less than 2000. Let's change that breakpoint. What?
Needed dot x.
There we go. All right, let's try that one more time. What do we got? I'm looking for... Wait. Oh, hold on. Parens. Try again. There we go.
There we go.
Wow.
Both a negative x by, and that's a considerable amount.
Yeah, and
okay.
Let's just see if
So
if one of these is equal to a negative number, is what I think I'm now looking at, right? Because we're playing over in this space, so we should never get any negative numbers while we're playing here. I just want to say, let's see, if new position dot x is less than 0. I think I'm just going to simplify this whole thing. Okay, one more time. There it is.
okay, so now we need to work out what is causing it to be set there.
135,000.
That's just not just a little less. That's like I walked out the door and ran down the street in the wrong direction, X.
Okay, that's cool.
That should be fairly easy to find, right?
Yeah, let's come back up to this line of code.
So the vectors are presumably X, Y, Z based as they come in.
Okay, so my percentage x has gotten negative, I think. I think this is part of my problem.
This is where we use the debugger visualizer, isn't it? To show all the component parts.
Yeah. Yeah. I'm just looking at the values here. So we have a 157, the upper left 3D. That's the upper left, the front left, three-dimensional point. That's its X value right there. So look, this right here should always be positive. The lower right 3D minus the upper left 3D. Is that right? Is that always going to be positive or no? Negative number minus, nope. It's also a negative in this case. Wait, what's going on?
Well, minus a negative should be a positive.
The bottom number is the one that's negative. But normally there's a negative up at the top here, so the whole thing is positive. So percentage X is like for the first time, I almost think, let's do this. Wait, not here. Let's do it here. And I want to make, put the condition here. I think we're going to find a correlation. I just want to see if there's a correlation right now, which is that is less than 0 between the time we're stopping and the other point too. I'm just hitting run here to try to get past all of this. Okay, let's try again. I think we're going to see there's a correlation with that X being negative. There it is. There's one, and there's the other. So I'm going to call that, yeah, there's the correlation right there. So that's at least the thing we got to be looking for, is this X getting negative.
Yep.
And then what are we going to do about that? I almost think that there's a min percentage here for the X. Should we make it just 0?
So this is happening as it goes to your right, which is the same as our right because your image is flipped on screen, right?
Yeah. It is. That's brilliant, Roy. I think we can stop right there, and that's as smart as we're both going to get today, I think.
Well,
no, go ahead. What do you want to say?
I feel like, isn't X getting bigger and bigger and bigger?
Until
there should be no cause for it to be negative.
Yeah, it goes bigger and bigger and bigger until we get to this point where we make things go negative because of the relationship between this vector X and that upper left 3D. The thing that's weird is my upper left 3D is over here, and I'm seeing vector X minus that position. I think that I guess like as an like I just kind of want to start poking at this, you know, like it's a black box, and I want to kind of play with it to see what happens. For example, I'm thinking about what happens if we just make percentage X never allow it to get lower than 0. What will happen? So I'm wondering what will happen. Will we be bounded by a frame in an unnatural way? Or
certainly, X should never get less than... I mean, if you say 0, that means it can't go off screen, in inverted commas.
Well, percentage X.
To the left. Oh, percentage X. Right,
yeah,
okay.
yeah. That's what I'm saying, not X itself. So percentage X is using these calculations down here, which is, I think, what's throwing things off because of the negative values. To be honest, there's enough math here, and my brain is small enough that I'm not going to be able to like really wrap my head around this in a short period of time.
Surly Dad is in the house.
Speaking of percentages, what percentage of the screen can I fill with pumpkins? So that's one idea. The other idea is creating some code to check, hey, are we radically changing from like a positive to a negative number? And if we are, don't stress it. Don't allow it or make it go away, I think.
Yeah.
Do you know what I mean?
Mm-hmm.
We could also do the same thing. We could do the same code without too much trouble in, hold on a second. Let's get, you know what? When I break here, I'm going to delete this code. We could do the same thing, I think, without too much trouble down here in TypeScript. because we're on one side and now all of a sudden we're jumping, far, far away is what I think is happening. Let's see here. Get thrown object from index. Position is equal to thrown object position. And I think I got to add the check here. I just want to let's see what those changes are up front. Actually, let's look at the changes. See what is that going to look like again.
If we're going to clamp or prevent one of the dimensions from getting too far out of whack, is that going to affect our check for out of bounds point?
I'm not going to do that. Instead, what I'm going to do is this. So look at this. Currently, the X is at 18,000.
Yep.
Okay, that's already been presumably updated down on the front panel, right? That's the X. My new X is now at negative 297. So we're going from a number very big to very, very small. I think the code down below could be pretty quick. Could be pretty simple to just kind of it's like repair code is what I'm suggesting. And so down here, I think what I want to do is I want to say, hey, if thrown position.x maybe do something like this. It's sprite. If sprite.x minus thrown by position.x, and I want to do a math.absolute on this. Sprite.x. Okay, so if the sprite's position minus this new position is going to be greater than, I don't know, 10,000, then I want to also similarly destroy all fireballs in return. I think that might be it. Let's try that. We might even, I think we could even say, we could even say 5,000, and that would be pretty reasonable, right?
Yeah.
Let's do that.
I assume so. I've got to wonder how it gets up to 18,000 in the first place.
Well, it's a thrown object, and we're using this small little, rectangle in 3D space to calculate where it should be. And sure. I think as we get further away from it, we the amount that we're off gets seemingly bigger. Also, we've got a wide angle lens, right? So it's not like this cube. We're translating a cube into a two-dimensional plane. We're transmitting this, would you call it a fulcrum or something like that?
Fulcrum? No, frustrum.
Frustrum. That's what it was.
Frustrum, as in frustrating.
Frustrum. I'm with you. Okay, let's reload. All right, let's see if we can get fireball. Throw it over there. That was too much of a... I didn't like that that last catch. I didn't like. Catch was like, where did we set that up? That was over.
It was a half second's worth of time we set. Yeah. There we go.
I didn't feel like it was a half second.
It didn't, no.
I'm hitting the SWAT command, but somehow Surly's surviving me. I'm going to bump it up to 0.6. All right. Finally feeling a little more reliable.
That just went a bit wrong.
Oh, did it? I didn't notice it.
Just once. Although weirdly, it felt like it had 2 ghost images, not just the one.
Okay, next thing I want to do, hold on, let's just get 1 to 2 cats right here. Okay, cool. Give it to me. My hand was off screen, but it caught it. Cool.
Yeah, still worked though. That was good.
And if I throw it too far back, I shouldn't be able to catch it. Uh-oh, that shouldn't have worked. There we go. So that one went far enough behind me.
Okay.
Min Z distance for catch right here. 300. I might want to drop this down just a little bit. Make it to 280. Let's try that. Just tweak it a bit. Where are you? I heard it fire up, but it's not on me. It's over there.
Fred's on fire.
All right, let's try again. Okay, that should have been a detection of the closing of the fist. Not a throw. Let's go check for throw. I'm going to say if we're in a fist, we can't be a throw. Okay, try again. Yeah, give me something. Nope, that's a fist. Come on, guys. Oh, because then it detected the fist was. Oh, that was so cool. I threw it backwards. Like this. Hold on, let's see. Can I get it again? It was like that. That's cool. And there, that's the Z. We reduced the Z plane there.
Yep.
Yep, too far away. Too far away. Yeah, Rory got the SWAT. Haha.
They look totally like you swatted him.
Yeah. All right, next. I think I want to add some gravity to the center point at which it's attracted to. So instead of it just always being there, I want it to suck towards it, right? Like that.
Okay.
And then even maybe orbit it if it has to, right? A 3-dimensional orbit around it. That's what I want to do. I'm not sure how to do that, Rory. I've got some math in here somewhere. Where's the attach point? Let's go find that. So palm attach point is here. Calling get attach point. Here's where that calculation occurs. So that's the place we want to go to. To make this work, we need to know where we were last. And do we also need to know its velocity? I think we might.
It's almost like you don't want to just go to where the palm is. You want to ease to where the palm is. Is that kind of what you mean? So you're going to move your hand, perhaps faster than it can move, and then it's just going to catch up. Perhaps initially at some relatively high velocity, but then easing down.
Did you see that? Surly was showing us.
I did.
How the swat occurred. Boom. Boom. Which should you be the next project? Using the leap to swat down the drones. Yeah, I thought about it. All right.
Obviously, some additional augmented reality to turn Mark into a gorilla and put him at the top of a building to be swatting at said drones.
So let's figure this out. We are moving. The thing I'm worried about is I think I need to understand what my current velocity is. That's what I think I need to know. I think I need to track my current velocity. Because I don't think it's because otherwise I'll be just starting from zero every time, saying here's the force. Yeah, I don't think I've ever done this before, where I have a stretchy kind of connected.
Can both be currently moving, and then you sort of accelerate away, and it has to accelerate to catch up, but then slow down as it gets close to its destination.
Mm-hmm.
That's almost what it is. So its speed should be inversely proportional to how far away it is from where it's supposed to be.
Yes, I think that's part of it, and it should be headed in that direction. But then once that direction stops moving relatively just a little bit, right? That's the thing, is that if it stops moving a little bit, I want to be able to have I want to be able to do, like, even tip my hand and have the thing, get a little orbit going, is what I think I want it to do, which means it needs to kind of know its speed. So it's like, whoosh, and then it'll even go out and come back. That's what I want. I want it essentially rubber banding attached to a point. It's not quite, at first I thought it was simply just a gravitational vector equation. Because if you do that, if I say, here's my point in space and I've got something else here, just using gravity equations, I've got this. But now if I move this...
Well, perhaps you break it into two pieces.
Yeah, I have to know
you have the sort of easement towards where you are, and then when you're within a given location, you kind of go into a wait state, which is just kind of dancing back and forth and what have you. Mind you want to have a certain control over it even in that state. So, yeah, okay.
Yeah, it's almost as if I think it's a different kind of equation. I think it's like, a spring kind of equation. Because like you said, Rory, the further away it is, the faster I want it to go, the more force I want to apply. Do you agree with that? Right? I want it to kind of, like I've got a spring and I'm pulling the spring around. And the tension of the spring is something I want to be able to dial up so it can, it can be very rigid or very loose, depending on what I want to do.
Mm-hmm. Yeah.
All right, let's see what we got. Let's see if there's anything out there on the internet that can help us. I want a spring equation, spring distance, maybe force equation. Okie dokie. Hooke's law. I feel like I know that.
Yeah, having flashbacks to college.
Here's your milk money. I don't know why I said that. All right, so let's see. What do we got here? What is it? F equals negative kx. Okay. I feel like I want an easier way of understanding this. Proportional K. So the force exerts on the string. Yeah, it looks like they're just multiplying the value by something, the distance. X is the distance. All right, so we're going to adjust force based on distance. We're going to apply that in 3 different directions because it's in 3-dimensional space. And is that all I need to do? Do I now no longer need... Yeah, I still feel like I need to know what my velocity is. That's what I think I need to do.
Don't we have this in the way that we apply the gravity? We must already be doing this to some extent in there.
That is not if we're attached to the palm. So the answer is yeah, we're kind of already doing that there is what we're doing. So let's, I guess I was just reading through the chat over there. Surly was talking about the drone fleet with Coding Gorilla. Yeah. Okay. Is the hand 2D created brand new every time when we fill in the frame? It is. The hand has got its velocity in 3D space, though. I'm pretty sure. It does have a... Yeah, there you go. It's got a palm velocity. I'm going to use its palm velocity with another object that we're going to kind of create. Oh, shoot. I need kind of like the old hand, or I need to know... The problem is since we're recreating it every time, we're not having that old object and matching it up to the particular hand. Part of the reason why I've done this is because if I have 2 hands on screen and I bring one away and then bring this one and then bring the other one up, what happens is the index that this is now hands of 0, and then if I do this, then this is hands of 0. I'd have to kind of figure out left and right and specifically track something for each of those 2 hands. That's what I think I'm going to need to do. I think that those might be static variables. So I've got a left hand kind of center and a right hand center. That's what I think I'm going to do. And I'm going to have an additional property on here. In addition to attach point, I'm going to get the floating attach point, or we'll create another variable, I think is what we're going to do. I think since I'm going to make some changes to the class, I'm going to close down. All right, so we want to have a vector, and I think it is BC is what I had for this. Was my shortcut for vectors. All right, so I'm going to say this is going to be a all right, this is going to be my right hand I'm going to call it the float point. And then we'll create another one called the left hand float point. All right, this is my gut telling me, this is a hunch telling me this is where we go.
Okay.
When we create the new hands, we need a method called get force on asking the question of the difference between hand dot palm position or not? Should it be the get attach point on it? I want to say
I'm
get
a little
attach
confused,
point.
Mark. Why does a single hand need both a right and a left hand float point?
Oh, sorry. Better?
Right.
These
so
are going to
any
be...
given hand can now know about those two facts.
Yeah.
That makes much more sense. Good.
Yeah, and then I need to do something like this. Hey, if hand dot side. Shoot, where do I get my side from?
Looks like
it's
his left.
Is left. Okay,
And
there we go.
hand side dot.
So hand if is left. I need to get my force vector, so I'm going to say VC force vector like that. Maybe I want to call this get spring force or get floating spring force, maybe.
Yeah, it's either that or like an attraction or I don't know.
Floating get attraction force. I like spring force better. We'll do that. It's a little shorter. And then we're going to say...
See, it's interesting. You will be able to do it. If we get this right with the spring force, as described, you're going to be able to pull your hand away from it, and then as it attracts towards the hand where it's supposed to be, you'll be able to take it out of the way and have it, in theory, shoot past and effectively rotate your hand and have the two orbit each other. That's exactly how a spring would work.
Yeah, I know. The problem is the position. We need to hold its momentum, right? We need to. The problem is my equation doesn't. The equation we just looked up doesn't give us a calculation of time and momentum. I need spring, time, momentum, position. I need that, I think, or maybe not momentum, velocity.
Isn't the force we've got effectively? It's like, how do I say this? It's inherently a moment in time in this direction, and then in the next moment in time. So it's like gravity doesn't really say anything other than, is it 9.8 meters per second per second?
Not true. Gravitational equations of position include velocity and time since that velocity started. Right? So if I throw a ball up in the air, it starts, my zero time is when it leaves my hand, and my initial velocity is used to calculate where it's going to be as it goes up and then comes back down. Isn't that true?
Yes, but what we're doing is the equation you've got is for the magnitude and direction of it, not for how long it's been operating. Just like gravity, you're told is 9.8 per second, but doesn't tell you how many seconds for the usage you need.
Yeah, that's kind of what I'm looking for. I'm looking for, something that can tell me a little bit more. Oh, what's this? Kinetic energy? Oh, man, I have to read through this whole thing. Yeah. It's like the other way around it, though. I think what we can do... I feel like I have to draw a picture of this. Tension, says Coding Gorilla. I find also if we contact the server for information, that's not good. What kind of information are you talking about here?
I want to draw some shapes. Hang on, let me check with Microsoft if you're allowed.
There are several scenarios. One, taking your private data and mailing it to Bill Gates. What? No. Okay, what is going on? Really? Come on. One more time. Another file is still opening. Please try going later. All right, fine. Let's just create a new one. All right, so stop. Jeez, please no. Here's my object. I don't know where I'm going with this just yet, Rory, but I feel like, yeah. So we've got a couple things going on. We have the spring force. Come on. So you've got the spring force going one way. There's like all kinds of things going wrong here. Really? Oh my gosh. I had to shift N to get it down over there. Why can't you just figure out what I want? Wait, and none of these are working? Wait.
You can rotate your text 90 or 270, but not 180, because that would be far too convenient.
Fine, we're doing it this way is what we're doing. Let's flip it horizontal. This will maybe work over here. And then you've got maybe my velocity. So this right here is just your standard gravitational equation right here, right? This is, you can use gravitational equation for this, right? Gravitational equation should work here, right? As long as I know my velocity, my position, and my time. Time since this point, this last point. Oh man, I want to be famous. I just want to be famous. And oh damn, did I just ban that guy? I was going to be famous. So it should work here. We need to know the velocity. You beat me.
So I kind of feel like the spring force equation you had before is for calculating the magnitude and direction.
Yes.
Which will give you the 9.8 component of whatever would previously have been your gravitational equations.
Right. Yeah, so we need time of the last... I think what we need is this. We need time and velocity of the last floating position. The spring equation, you know, F equals the spring equation.
KEX or something
like that. Yeah, something like that. F is equal to negative kx, I think is what it was. Like that.
I think so.
Calculates the force. The spring force. Like that. And then so I think that's what we do. We track time and velocity of the last floating position. That's what we do. And then we use that, we update that based on where it is. That's going to, hold on though. So we've got the velocity of the hand, but do we have the velocity of the object? We don't have the velocity of the object. This is where I think we're going to get into trouble.
I don't think the velocity of the hand affects the velocity of the object.
I think you're right.
I think the velocity of the object is purely based on where the hand has moved to.
Yeah, I think you're absolutely right. And I think that's, you know, part of the problem in my head is I was thinking we could use the hand velocity, but that's not, it doesn't seem true. So that means we need to calculate the new position of the object based on the last position and the time, the last position, time since last position, and last velocity.
Yeah, you need its last velocity and the velocity calculated by working out the relative position of the hand and the attractiveness to it.
It's on the last position where it was in, the time since the last position, and the last velocity. But I think we're using the new spring force.
Yeah.
Okay, then...
Which itself is relative to the current hand position.
Yeah, and maybe is that all we need to do? That might be it, all we need to do. I was thinking then we need to take the new spring force, you know, and then calculate further, but I don't think that's the case. I don't think that's the case. I think it's simply this paragraph right here is kind of the key. I'm going to get rid of that. We need to calculate the new position of the object based on the last position, the time since the last position was taken, and the last velocity.
Now we need to be careful. Let's say that we're distant enough, or in the last frame we were distant enough from the two objects x far apart to be giving us a velocity of, I don't know, 10, 20 units per second in the correct direction. We need to apply the new spring force to that based on all that previous information, such that we, I guess, accelerate towards our destination. But as we get closer, we're not wanting to add, we're not accelerating the whole time. We want to actually get slower as we get there.
No, I don't. I want to, well, I want I'm okay if it doesn't get slower. I'm okay if it shoots past it, I think. Is that true or wait? No, you're right.
Absolutely.
Well, I know. We both said you're right at the same time to the other. Maybe you're right.
Well, there's two very justifiable effects that we could go for here.
Yeah.
One is the braking force as you get towards the palm. Okay, that would need to happen. Or alternatively, you're right, we could have it overshoot, and that's what allows for the orbiting in a natural sense, unless you want to switch to a new model as it gets within reach of the palm.
I'm trying to visualize it. I'm trying to envision it, right? I'm like thinking, you know, if I move my palm, you know, it's kind of like this kind of a thing that I want. I want it to feel alive. Do you know what I mean? And so by giving it this kind of thing, having it overshoot and things like that, I think.
So I think you're right. The overshoot's good. And we can always be accelerating towards the center, and if the center's moving, then as long as our acceleration is in 3 dimensions towards wherever that point is, we should be all right.
All right. So here's what we need. We need new position, new velocity. Both have to be calculated. So we get new position based on that. Then I think we get new velocity from that as well. Okay, so that's. I'm sorry. I know this is not sounding very clear. Let's go ahead and get these pieces. We need to store last position. The time of that last position was taken a snapshot of, and its velocity. So position, time, and velocity need to be together. Do I need to create a new class? Maybe I do.
This is data for the thrown object, though, not for the hand.
Yes, it is. But what I'm going to do is I'm going to change this to the new class type. That's what I'm going to do. So I'm going to be like, I'm going to call this like the floating point, the floating attach point. And we're going to have a vector called position. We need another one called velocity. And we need another one. We need something in here that's going to be time? Snapshot time, maybe? Kind of to indicate where we were in time when it was taken.
Okay.
Now then I'm going to have my floating attach points be here. Do that instead. And I think what I want to do is I want to say floating attach point is equal to, and I'm going to say get floating attach point. So we've got these two static pieces here. And then I'm going to have a local property just called floating attach point, like that. This is going to be a scaled point, like that. So I'm going to call this on it. So we're going to get our force vector first. We need to pass in a hand. Okay. We're going to figure out get attach point is 3D, right? Yeah, it is. I'm going to rename this to 3D. Good.
So that's what's got me slightly confused. You see, you're going to get a floating attach point, but then you're going to return it as a 2D point because scaled point is X, Y, and scale.
Yes, I will. So I will get it in. All right. I'm gonna get it in 3D and then I'll convert it the last minute to a scaled point. That's what I'm gonna do.
I was going to say, because up until now, scale points have been used effectively for rendering on screen, but not in any mathematical equations.
Yeah, but that's what I'm gonna do. In the hand 2D, we need to kind of get that 2D, that scaled point, so that we can send the data down.
I keep forgetting we are.
Tell it where it's going to actually go to.
2D.
Yeah.
Okay.
Because even if it's spinning in a circle in 3D space, I want it to look like it's spinning in a circle in 2D space when it's rendered. You know what I'm saying? So. Okay, get floating spring force. This is going to be from the attach point to the left hand float point. Do I need... maybe... Let's do this. Let's generalize this a bit. Let's change this a bit. We're going to change this to floating attach point 3D. And we're going to say like that, and then we're going to come down and we're going to say return that dot to scaled point, like that. Okay, then we're just kind of hacking away at this, getting one piece at a time in here. So get floating attach point 3D. It's not getting easier, but we've got an attach point 3D. This should allow to get us our force. So our force vector, I feel like I'm a mathematician. I wish Will Bennett were here. He could help us. Get force vector. Maybe call it get spring force vector. And we're going to throw in the attach point and the left hand float point dot position. Okay, so get the spring force vector. Step one right there. Spring Force is more fantasy comic, like Speed Force. DC Comics, The Flash. Okay, so now what we want to do is we want to say attach point 3D minus position. Let's see if we can declare a local for that. That's going to be our force vector. And am I just going to multiply this by a negative k? Is that what I'm going to do? Like something like that? Some negative constant? I think I am. All right. That's my F equals, I was thinking more sci-fi. Use the spring force, Luke. Sure. Sure. Using Kodosh's latex formula support here. F is equal to kx, k negative x. Can you check that formula, Rory?
Sure.
I'm pretty sure that's right. I just want to make sure that we're
That's what I'm thinking was
crazy.
correct, but yes,
Yeah.
good, worth checking.
like that. All right, so that's what is going there. There's my k right there.
Seeing Hooke's law, F equals kx, not negative kx. Which I honestly thought we did see.
I thought we did.
Oh, no. No, it's a typo in part of it, that's all.
Okay.
The main body of the thing does say negative kx.
Okay. This is the first time I've used a single letter variable name in my life right here. So we'll say k is equal to 3 for now, and then we'll say force vector times that, and spring force equation. We're just applying it to the vector. We want that to be a float, actually. There we go. Okay, so we've got a force vector. Where's our gravity equation? It's out in physics, right? Physics dot. Got all of these pieces here. Do I have something on? Do I have an extension method on force vector? 2 meters per second. What's happening there? Millimeters per meter. Oh, I see what's happening. This is our conversion from that. Get current position. Here's some physics. Get displacement meters, right?
Mm-hmm.
I feel like I might need another vector around here. Oh my gosh, who's here?
Wow.
Look at that. Oh no. I'm trying to write code in aliens. This guy's like, hey, look at that guy. Get him. I got him. Did we get him? I think we got him.
He gone.
Legendary Moo is here.
Welcome, Legendary Moo. It's been a while.
All right, so we've got another, physics has got get displacement meters, but it's also got get final velocity meters per second. That's the one I'm kind of really wanting to work with here. And I'm suspecting that I'm going to be able to do that in all of these dimensions here. Get current position and meters to pixels. Where's get current position used? Virtual 3D object, current position. Let's see what I need in here. I need the time in seconds. That's my delta, right? I need my initial velocity, and I need my acceleration. It's the exact same parameters, is what it looks like.
Basically, it's all the same stuff, except we're not hard coding gravity. We're allowing an externally force to be specified. Is that right?
Yeah, what I don't understand here, get final velocity per second from a double to a float, meter to pixels. Let's change this to a float. Change this one to a float. That means we're changing these to floats. Right, I feel like you said something and I missed it.
So our method that we were using, that you just duplicated, you duplicated a copy, and essentially I think the only difference between what you want and what you have is that what you have effectively hard codes gravity as the force that we're trying to apply, whereas this one is, you know, you want to pass the force in effectively, the additional.
Yeah,
right.
Well, the force, we're gonna, here it says gravity, but we could call this force right here. Same thing up above here.
Fair enough, yeah.
I think that may be what you were getting at there. And then we're just gonna, we're just gonna be passing in the force. So get final velocity, correct. That's what I want. And that's gonna work on a vector. So this is an extension method for the vector. Cool. So because in our notes, we said we need the new position and the new velocity based on the last position, which is going to be a vector. And we're going to say, we're going to basically call get current position on it, passing in, you know, this is an extension method on itself, the force, initial velocity, and delta time, and the last known velocity using the new spring force. Yeah, I think we can get it. There's a shot. And there's also a shot, we just sat here and talked a whole bunch and didn't do anything. There's a chance of that too. Let's go back to where we were. Okay, so we've got our force vector. We then want to go with this is our floating attach point. I did not think this was going to be that complicated. And then we want to say, oh shoot, we can't go this simple here. We need a little more in this space here. We need to store the values as they're changing. Last time I was here, we were still working on the bot for Dragon Humpers. Oh yeah, here's what we're working on today, Legendary. I can't show you. We're working on fireballs.
We moved on from that.
We're throwing fireballs in three-dimensional space. That's what we're trying to do. Doing some math.
Even what we've got is very good already, but we have the ability to cast fireballs, to throw them backwards and forwards and catch them. What Mark's wanting to do now is to have this idea where a fireball sits in the palm of your hand, just hovering ever so slightly about that, and you move your hand away, and the fireball doesn't remain permanently attached so much as it trails it by a certain quantity. So you move your hand to the right, and then the fireball catches up and maybe sort of just orbits ever so slightly in the palm of your hand. A very cool effect if we can get it right. And for this, we've looked for an equation to help us. We found, I think it's Hooke's law, would give us a spring force equation of sorts, and that's what we're trying to add to the system as it stands now.
Yeah, that's what we're doing right there. Okay, so we've got our getting spring force vector. I'm pretty sure that's right. We may find that we need to flip this to negative right there. That K may be a negative right there. It was a typo, right? It should just be KX, right? Is that what it is?
I think it actually is negative KX. I think that there was an initial typo on the page I looked at, which initially referred to it without the negative.
Okay. All right, cool. So it just means we're flipping back, going in the opposite direction of the spring, which is...
Effectively, it's the inverse square as opposed to the square law.
Yeah.
I think that's...
Okay, so now we need to... We've got a point... floating points. So we need to find where it is here. So it's get current position is what I think we need to call. But before we call get current position on it, we need to call get, what is it, velocity? Final velocity? Get final velocity. And we need to get the previous force, which I think is in floating attach point. Did I store that or no? I'm going to need to store the previous force as well. The last force vector. So we'll call it like last force vector. Or last force. Like that is what we'll call it. So let's go into floating attach point. Create a new one of these. Call it last force with an uppercase L. We'll do this. So the final velocity, we need its initial velocity. So we're going to say floating attach point dot position. Nope, sorry. Velocity. And then the delta time is going to be daytime now minus floating attach point. Oh my God, this is making my brain reel. Minus snapshot time. Okay, so that's going to be my get final velocity call right there. Okay. So that's the final velocity. So get current position is now going to need my force vector. It's going to then need that final velocity. And I think it's going to need the same delta time. Yeah, because we're kind of blending data from the last, what we know last with now. This could fail spectacularly, this code. This could be like so crazy and not work. And it could also barely work, but I'm feeling like I'm losing it a bit. And no, not yet. Fred cannot catch fireballs yet.
That said, he is impervious to fireballs, so he doesn't really need to catch them.
They float by him. He can lift his hand up. That's about it. We might be able to do that. I might be able to get some, catching animation for Fred. We'll see. All right, get current position now. Here, this is, I think we need a local for this, like that. So now we have a new final velocity. And if all of that code before is correct, we're going to come in here and say velocity is now equal to final velocity. I think that's correct. And then we're going to say this is equal to my current position. Whoops, I meant to say floating. And then we're going to return, I think, our current position. And I think we're also going to say snapshot time is equal to now. And I'm going to make now a, I'm going to introduce this here so there's only one. Like that. Okay, Rory. Look, my head's going like... It looks like a Michael Bay movie inside my head right now. And all of me is walking away, not looking back. I don't know if you're any closer or not. What do you... This is like built mainly with intuition. What are your thoughts at this point? You like run and try it, I bet, aren't you? You're like, let's just see. I got to go, Mark. My time's running out.
It could be absolutely right. I mean, I do see your point. We are sort of trying to do quite a lot at once. There are concerns over some of the code is very definitely, let's make sure that, because we operate in this space of updates, so we need to know relative to the last update what the change should be.
Oh no, I'm still here. I'm not there. So yeah, we don't have that directly connected. I'll sometimes hit that button to make that go when I see it. Sorry, Rory. So what do you think, Rory? What's your
That's all right.
what do you think?
I think it's got a fair shake at winning. You know, it's quite possible
I feel like
this will come out in the wash. I think you've followed some consistent strategy as you've gone through it. So
all right, I just gotta run it. I think I'm like
yeah.
I'm like I feel like I've let's see. I like how he hit that button right in the middle of Roy's response. I know. I didn't think it was gonna be that loud, but then I realized after I started it was a big mistake.
I'm just wondering how I'm going to explain that. And
Whoops.
my kids walks in and sees that.
They're just cats. I don't know. I feel like maybe I'm in trouble. Maybe we shouldn't be playing that one for here. I got here's some dogs in the background trying to get out of here. Oh, well, we're not doing anything yet with it. So right now there should be no change. Okay. That's actually good news. Well, actually, let's break everything. Let's stop everything for a second. There's two things I want to do. I want to avoid an initial really strong force. The position, the initial... I need to do this before we get here. If that's there, then I'm going to say that's equal to a new floating attach point. That will give me vectors that are all like zeroed out. But I think what I want to do is I want to... Hold on, let me move this up a bit. Where's my get attach point call? So I've done that, and then I've got a zeroed out force and a zeroed out velocity. We're not actually storing the force, are we? Maybe I don't need the force. I said I did, but now I'm not remembering why. Suggestion for party 4. Okay. All right, we'll see. We'll see, Coding Gorilla. That's a mess. That's going to be hard to separate. Okay, Rory, you need to leave, don't you?
I kind of do, my friend.
I can tell by you're like the stress around your mouth as you breathe in. Is you're like I have to looking for an opportunity to jump in.
That's an actual alarm, look. Yeah, no, fair enough, my friend. That is true. I do need to leave. However, I will be available and back with you tomorrow.
Thank you so much.
All right then. See you later, man.
Bye, buddy. All right. Roy wanted to see it working. We'll see how we get here. Don't report murky. Okay, get floating attach point, 3D. Let's see if I can get my head wrapped around it. Oh, here. I think that's kind of it right there. Okay. And then I want the same thing here for the first one we create, but with the right hand. Okay. That takes care of some of that problem. Gets us this initialized piece. Yeah. I think I need to do that now, actually. Let's work on that right now. So I want something that basically says, if not has hand. No, I guess I'll just have to say has right hand. Then that is equal to null. And if not has left hand, all right, so it doesn't have the right hand. We're going to set that data to null. If hand dot is right, then return true. Otherwise, return false. Duplicate that. I think I want a coder's feature request. All right, this is a feature request for duplicate selection. I have this, I want to duplicate it. Let's say we get to here, so I'm doing it for the first time. I come in here, I select just the word right, and I type in left. At this point, and I'm not sure how to do this, guys, so I'm sorry for this, but at this point, I wanted to pick up all the other camel case lefts in here and say, oh, do you want me to get those too? Or alternatively, why isn't it connecting those camel case pieces up? If I come in here and I say select this, why doesn't it get has right hand and is right, connecting them both? It picks up that I want to change this, but it's not getting that I want to change that. I guess that's it. I'm not sure if there's a bug or a feature I'm talking about here. Anyway, that's what I'm looking for here. So let's maybe call it an issue for right now. And we want to say duplicate selection. Match. Camel case matches are missed. Like that. Before I go throw this out there, let's bring up my CodeRush options here. Why am I not seeing smart duplicate selection in here? Smart. Duplicate line. Don't we have options here for it or not? I thought we had options for duplicate line. Include partial matches. Is that my problem? That may have been my problem. So maybe it's not an issue. I think that was my problem. All right. I'm not going to report that right now. I think we're okay. Just my settings we're off. Okay. All right, I think let's start running again. Let's run it. That issue feature of the bot is great. Yeah, it is. It really is. The only downside to it is that the recorded issue doesn't last forever. It lasts like, I don't know, about 30 days or something like that. 30 days, 60 days. So we should see no change in behavior. Let's see if this at least still runs with no change in behavior. What do we got here? Null, which is null here. Initial velocity. Yeah, Twitch deletes the videos after a certain amount of time, right? Right. So, like for example, we'll put an issue in Trello, and Trello will link to the video, and I'll be like, "Okay, guys, you can't just link to the video because that's not going to be around. You either have to fix the bug fast, or implement the feature quickly, or you need to somehow get that video in another form, get that information in the video in another form." I think I want to fix this before we get here. All right, let's close it down. All right, so no change in behavior yet. So everything's still working. Yeah, this is tipped up way off to the side here. This is probably better. There we go. Okay. Okay, let's see if we can make use of that other point and see if things go totally crazy. So hand 2D has a new property called floating attach point. It's a scaled point. So we're going to go over to TypeScript, look for hand 2D. We're going to do that. There's our floating attach point. And then I'm going to go find my palm attach point. I want to change it everywhere. Okay, so palm attach point is only used for when we put out those messages caught. What about this? This is called get hand attach point is called get first hand attach point. Get hand position from side. Get hand position from side is called right here where we decide where to put it. So I want to change this. Create a new method called get floating position from side. Called get floating attach point. Extract this to its own method. Let's fix this. This is not looking, I don't like this at all. Let's have this return to scale point like that. Okay, that's a little bit better. Okay, so now we've got that being called from get floating position from side. That one's not being called yet. Got hand position from side. We want to change this to that. Comment that out. All right, now we'll see just how bad or good that code is. All right, I'm nervous. I think it's going to be bad. Already sounds bad. Looks bad. It's like nowhere to be found. Oh, wait. Yeah, it's not good. Not good. Let's restore that code for a second, refresh. Okay, so we got some problems somewhere. Yeah. All right, so the floating point code is not working. All right, that was Mark Miller School of Acting when you saw me look at the virtual fireball that didn't quite exist in my hand. All right. I don't think I want to go after it, is what I'm thinking right now. I want to take a break and go after it again tomorrow. That's what I think I want to do. Yeah, I just think that might be a good thing to do because my head's a little bit on that. Let's get a raid going. I'll send you over some competent coders on the live coders team. Bald Bearded Builder, what you doing, Bald Bearded Builder? Starting soon. See you tomorrow, Coding Gorilla. Let's see what's we got. Honest Dan Games. We'll send you over to Honest Dan. See you tomorrow, kids.